constructs that is mostly in the tech ecosystem. That is these are systems that will be brought to you, will be launching out from Space Tech very soon. I think probably next week, the following week, so that you could be able to meet any mentor or mentee if you're in any of them. So to sign in or to sign up for the waiting list, you'll just get into mentor list. Uh, Jimmy, you'll help me share the URL of the mentor list platform. So it will be mentalist.co.com. That is a mentalist with LILST, mentalist. So just to introduce the session today that you're going to tackle, that is how to master database engineering using SQL. The speakers today will be handling that is Faith Kilonzi. So Faith Kilonzi will be welcoming you to introduce more yourself, then take off the session on your end. Thank you.
Thank you, Juma. I'll also be inviting Faith so that you can start us off. You can tell us about yourself, then you can just start the session. I'll be looking out for questions on the chat, and if you have burning question, you could actually just raise your hand, and I'll be giving you an opportunity to speak.
Faith, the floor is yours.
Okay, sure. Okay, so hi guys. How you guys doing? So for those who do not know me, my name is Faith Kilonzi. I am a software engineer, and I'll be taking through this session together. So I'll do a bit more of in the introduction while I start, but I can see Bruce has a question. Bruce Simiu, you have a question?
Yeah, I'd like to ask something.
Okay, go ahead.
I don't know whether I've asked too early, but what do I need to consider when I'm selecting a database as a front-end engineer?
Okay, so do you have like a specific use case that we can work with? Why do you want to apply this database? Are you asking from a place of which technology are you using, SQL, SQLite, Postgres? What exactly?
I'm just getting started.
Mm-hmm.
Yeah.
But you mostly do front-end development.
Yeah.
Okay. Personally, I think for every beginner, you need to understand just the basics of SQL, because I think SQL is like the fundamental database that everyone should know. And because you're a beginner, it will give you a kickstart into the other database technologies.
Thank
Can
you.
you start, then you bring the questions later, right?
Yeah, thank you.
All right. Okay, nice. I'll switch off my video just to take care of the bandwidth, then we can start. Okay. Hi, Karama. All right. So basically what we'll be talking about is mostly just database engineering, but I prepared this to be at a very, 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 very basic level. It's the fundamentals of the fundamentals. So you don't have to worry so much about the jargons. I'm sure there are very few. So thank you. Also, before I start, I want to thank the Space Tech guys, especially Lawrence, for inviting me for this session. And I'm hoping that people will take a thing or two from it, and also that it's a start to many things that we're doing in this space. Yeah, and thank you everyone for coming. It'll be crazy to be here on our own without all the audience. So we are hoping that you guys will come through and to have a better discussion while at it. All right. So you might not have heard about me, but this is basically about me. My name is Faith Kilonzi. I'm a software engineer. I do DevOps consultation. I do big data, and I also do technical writing. I I have a background in computer science, and I'm currently doing my master's in big data technologies. I've worked in different industries for quite a bit. I've worked in edtech, which is currently what I'm mostly enjoying. Then I'm also worked in fintech, banking, and DevSecOps spaces. I also host and I founded podcast. We talk about all things tech. It's called Global Tech Sailors. We talk about all things tech and how to navigate the industry. If you want to get in touch, you can find my bio across different social media platforms, especially LinkedIn, Twitter, and my blog. All right. So this is how this session is going to be. It's a bit of theory and a bit of practical. The practical is not as much, but I'm hoping that we are going to integrate the two. I'm hoping that maybe on the chat we can have questions while we are at it. And also, I want to make it as interactive as possible. So when I ask a question, make sure that feel free to raise your hand, respond on the chat. We're just going to have fun while at it. So I'm hoping that we can do that. Yeah. So at the very basic level, I'm hoping that by the end of this session, you should be able to understand what does database engineering involve, what are some of the principles that everyone should know, and the fundamentals of SQL databases. Then hoping that we'll also be able to apply a bit of those principles into an hands-on exercise and hoping and we'll be using an e-commerce use case. So that's basically what we are working with today. um, but maybe let's hear from right now we have a couple of people here. So I just want to ask from anyone to give us a basic understanding of what they understand by database engineering, or you can give us an example. Give us an example that of a project that you're building or you built before that you're proud of and how you've applied databases to it. Or you can say, maybe I'm building a clone of Netflix and I'm using SQL database to do this. It doesn't have to be SQL. You can give us maybe how you've applied maybe databases, the concept of databases this week or previously. Just give us an example of like where you're at. Have you applied a database before, database concept before, and which project are you working on? Just so that we know where people are at. Shadrach.
Yes, hello.
Yes.
Hello. Can you hear me?
Yes, we can hear you.
I have a project I want to undertake. I
Mm-hmm.
think I'll need so much of the database engineering.
Mm-hmm.
The project is about it's a location-based service
Mm-hmm.
whereby I want my users of my application or website, they have to enter their location of their businesses, whereby if you search for their business, you can see their contact. You can have their place, their location. Specifically, we are going to use the latitude and the longitude. So I would like to store this information in a database, specifically using SQL. That is where I can retrieve the information using an API. So where the user can come if she wants to look up a certain business. The business can be shown from the database because the information is to be stored in our database. Thank you.
Nice, nice, nice. Please, all the best in your project. We hope that if it's private, fine. If it's public, then you share it with us. Maybe a snippet once you're done, right? Yeah, it would be nice to hear. Bruce, you have your microphone unmuted. So do you want to speak or do you want to mute the microphone?
Let me mute. Sorry.
Okay, sure. Nice. Okay, Gideon is also saying that he's studying a course on Coursera on database engineering with Meta, market analysis with Meta. That's good stuff. That's good stuff. Nice. So, a few things, right? And I know sometimes when we talk about databases or when you talk about programming and computer programming, software development, there are a lot of factors to it, or there are different types. But by the time you whether you're a mobile developer or a full stack web developer, or you are just a backend or a front end developer, you still need to understand how the web works. So usually how this thing work is that you need to be able to know by the time you're maybe coding that site or web application or mobile application, or you're a front-end developer, you're designing that those interfaces, or you're a back-end developer, you're trying to just create APIs for the front-end guy, you need to understand how data flows from the browser client to the database and vice versa, and how that information navigates the web, right? So at the very basic level, there are different architectures to web development and how the web works, but the basic one is the three-tier one, which is what you see on this image. So what usually happens is this: you have a browser client right now. If you go on your Google site or on your Google search and you go to, let's say, I'm looking for, just searching anything like Spacia Tech, I should be able to. What has happened at this particular point is my Google has fetched. So it has. I've gone to the browser, given it a text called Spacia Tech. Then what happens is that is a request I'm making to the different servers on the web. So it's taking that text and querying different servers across the internet to be able to give me a response. So that's why you can see now, based on that, I can see Spacia Tech official website. I can see the Twitter. I can see the GitHub. You can see everywhere that this word or key phrase appears, right? So, but the back end of this is what we have on this image, where on the browser we type Spacia Tech, then we send that information as a request. Then it goes to the servers across the web to look for matching phrases. Then after that, it will give us the response in form of an HTML file and in form of the different text and the different markup context that we've been given, like you've seen on that particular point. Of course, there are different technologies for everything, or for every particular part of this basic structure. There's a browser, depending on which browser you're using. I'm using Chrome, but it doesn't matter as long as your request can be sent. Then there's a server machine. Where is this information stored? Is it on a database? Is it on a file? Is it, all these things are all together. They are all working together to make sure that the request and the responses are communicating with each other. While still at it, when we talk about now full stack web development, and I'm just using full stack web development, but also it applies in the mobile development, because you still need to store data somewhere, you still need to fetch data, you still need to work on a logic to make sure that the data is displayed and also worked on the same way that you need it to work on, right? So I said there are different architectures, but the basic or the most common one and popular one is the three-tier architecture. Usually, an application is split into three separate logical layers. There's the presentation layer, there's the application, and there's the data access. Today, we are only interested in the data access because that's where databases lie. If you see from this image, the second image, you see that we have different clients or browser clients or different computers making requests. Then before the database, we have the basic the business logic tier. Let me use the example that was it Shadrach used. So Shadrach said that is building a site for maybe business listings, right? So if you want, maybe if he's listing businesses in within Nairobi, in different, I mean, people in Nairobi are selling different things. There's someone doing wash, there's someone doing there's someone doing cosmetics, there's someone selling cars, there's someone, like, people are doing different businesses in Nairobi, right? But now, before we can get to if you are searching, there is no way that we want to make sure that this site is so nice that when Shadrach builds it and someone is searching for maybe cars, you're not brought, if you are just searching for cars, you need to make sure that the request is about cars, or we only list businesses in the category of motor vehicles or something, right? But now if you are looking for something, so for that logic, the logic to be able to differentiate between maybe wigs and makeup to cars to these other things that people are doing, it's based on it's happening within the business logic layer. So I know the application should be able to understand that I've searched for cars and I've not searched for cosmetics. So that differentiation of the logic to be able to know, only filter out, this is the exact thing that I'm looking for. So that is what is happening within the business logic layer. Then obviously now within the database is where all the information, all the information about businesses in Nairobi is stored. So when you say you're a full stack developer or you're a full stack mobile developer, whatever, you need to be able to understand how is the data stored. That is the database. Then how is the data presented in terms of, okay, do I want these cards to appear at the top, these cards to appear at the bottom? Do I want this text to look like this and all that? Then at the core of it, so the presentation layer is about what is presented. Then business layer logic is about how that information is flowing. Then the database is about how that information is stored, basically. So all these things, all these layers work together to make sure that your site is end-to-end understandable, and also make sure that it's solving the problem that you want to solve. Because at the end of the day, software development, software engineering is about being able to solve problems, being able to translate what a customer wants into a real software solution, right? But before we get there, now let's talk about now the database. And the databases, database management comes in different parts. So, but at the very core, or the umbrella term for it, is the database management systems, which is a collection of interrelated data and collection of programs to access that data. So this can be divided in several databases types. So one can be a relational database or non-relational databases. Most of the time when people talk about relational databases, only SQL comes up, but it's usually one of the building blocks for relational databases. But under it, there are a lot of, there is MySQL, there's the Microsoft SQL Server, there's the Oracle database, IBM DB2, a lot, like so many under relational databases. Then we have non-relational databases, or they are also called NoSQL databases. So we have the MongoDB, we have Apache Cassandra, we have Redis, we have Couchbase, we have Apache HBase, and all that. So we have a lot of examples under each. But what differentiates them is basically this. When we say something is relational, it means that data is related, or the data that is stored is related in one way or the other. For example, if we were building an e-commerce site and we wanted, or a Jumia clone, we'll have maybe a database about, we have the database that is hosting the entire data or information about our e-commerce application. Then within that, then we have things called tables. So the table is what differentiates or what stores related information in smaller batches, right? But now here's a case where you've ordered a product. We want to store, we have a collection of products that we are storing. So we have maybe a table for products, right? Then we need, these products come in different categories. We have a product for the product that is maybe electronics related. We have another one that's furniture related. We have another one that's that is related to the home and all these kind of things. So the different categories of these products we need to make sure that by the time we store this data, if we are storing data about maybe a TV we want to sell, then it needs to be stored or related very well to make sure that we know a TV is under the category of electronics. And if we want to have another product like a book, then that's stationary. So these are different categories. So for this data to make sense, and going back to this architecture, for this information to make sense, for you to be able to know, by the time I query, I'm looking for a TV, I shouldn't get a plant. It's all this related thing to make sure that if we have categories, to make sure that by the time I query, the category is maybe put into consideration within the business logic to make sure that whatever I get as my search result makes sense or is within what I've looked for. So that's where relationships come in. And this means that you're trying to make sure that the data you're storing is related with or is makes sense in different categories or something of that sort. Then when it comes to non-relational, one of the common ones is MongoDB. MongoDB, it's usually you have like a lot of data or a lot of unstructured data. So when I explained relational, one thing I forgot to mention is that relational database or SQL databases are very much like you have information that is very much structured and you know what fits where. But now imagine if we were building a site for the government and we want to find out what are some of the, maybe we want to store information about maybe marginalized communities in Kenya or people affected by something, maybe people affected by the drought that just ended. We have a lot of information that we are working with. Yes, we can structure it in a relational manner, but imagine now every community uploads documents about it, we have 47 counties, and within those 47 counties there are different districts, there are different even villages. Like there's a lot of data that is related, and in this case maybe village A will give us a document that is not necessarily in line with what village B is talking about. Then we'll move to the other side of Kenya and we'll still have that information. So we have so much unstructured data that we need to work with, such that we can't be saying that, Nairobi County is related to Kiambu County or something of that sort. We need to make sure that the most important thing is data collection in this project. So you see, our use case has changed from just being able to maybe query to now we need to collect data. So in this case, you've collected data, it's unstructured, it's difficult to keep up. So how can we store it? We use an unrelational database to make sure that at least we know when we query for Nairobi County, we should be able to get that data. When you query for this other, but it doesn't necessarily have to fit a particular format. You just need to make sure that it's stored. Then so that's the main difference really. But today we'll be focusing on SQL. If you're interested, you can read more about non-relational and relational databases. Most of the time these different databases are applied separately or differently depending on the use case. For example, for my SQL, Microsoft SQL Server is mostly applied in maybe enterprise companies. See, some people, if you're working maybe for enterprise companies, let's say you're working for a banking company, or you're working for even Microsoft. These typical corporate companies, you're most likely to use Microsoft SQL Server. And also now it also depends on, is this company under maybe the Microsoft suite products, that kind of thing, that will maybe require them to use Microsoft SQL Server. Are you working with maybe C# and those kind of Microsoft related products, they are more likely to use that. Oracle databases as well. So all these ones, you choose them based on the use case, based on the project and what you want to do. But the underlying technology is SQL, which stands for structured query language. And it's mostly about being able to store data and manipulate it in a structured manner. Before we get there, we have now the different types and database management systems. But the basics of the basics is being able to define the data, record that data, or keep a record of that data, query the data, update it, manage it, all these other things. So these are like the underlying functionality or the key functionalities of the databases. Then we already said a database is a collection of logically related information organized that it can be easily accessible, managed, and updated. And it's usually accessed electronically from a computer system. And it's controlled through a DBMS, which we just discussed extensively previously. I'll move faster here so that we can get into the practical aspect of this. But we already said that you need to be able to structure the database by defining the tables, the fields, the population, and then being able to populate the data, query the data, report on the data, then modify the data, then modify the structure. I already explained relational databases, so I don't think I'll do a repeat of this, but mostly a relational database, like we said, it organizes data into one or more tables, each of which consists of rows and columns. So it makes sure that the data in different tables that is related to each other is it can be linked. So, and when you use a relational database with the underlying SQL, you should be able to create complex systems to and structure complex data models for your site. We'll get into the details of what this is about, but now forget about now the concept. The key concept behind what we are just talking about is basically being able to engineer your backend system or database engineering for backend development. Mostly the backend developers would be the ones concerned about how data looks, how data is stored. But as a front-end developer, you need to also be able to understand how is this data. If you need an API for displaying products, you need to know how is this data stored for me to be able to display it. What are some of the maybe fields being used? What are some of the, if I want to display just the name and the image, is the image in form of a link or is it a blob? Those kind of things, you need to be able to understand the structure of the database or the of the backend database for you to be able to interact with it. It is at the very core of software development, whether you're a front-end guy or a back-end guy, because now imagine this, you're applying for a job as a front-end developer, but they will give you an API to consume. You need to be able to know how it at the very core, can you even go through the documentation of an API for you to be able to use it? So very, very, very important for you to for you to be able to understand how the database is engineered for you to work with it. Then SQL now helps you to interact with the data, be able to create, read, update, delete from a database, and perform the different varieties depending on the use case. So right now, I want us to do a short exercise. Yes. Okay, so I'm big into what I'm doing, so I've not yet been able to see what their questions. But Brian, yes, I'll share the resources you have. So right now, I want us to do something. We are building something. We are building an SQL. We are building a database for an e-commerce site where basically it looks like Jumia. So let me go to the Jumia's website and let's understand it from that point of view. So right now, if we Okay, fine. Okay, so this is the basic Jumia application right now, based on what you can see. So we have different, when you're creating a site, you think about the data, and you can see some of the data that is being displayed on the front end, right? We can't see the database, it's on the back end, right? But we can see a couple of things here that are being displayed. But based on what you can see right now, is there something that, what are some of the database tables, or what kind of information do you think we need to be able to build this kind of site? Now think about it from a backend POV. Okay, Emma is saying that database is for products, users, products, customer information. Okay, so I can see people saying database of collecting, database of. So there are different terms to this. Maybe before we get there, there's something that you need to understand. The database, so the concept of database is it's now the umbrella. But now for us to build this site, we need to create a database first. Then within the database, we will create different tables. The table is under the database. Then within that table, we store now related information. That's why we have some people, Evans, Eme saying products table. So a products table will store information just based on products only. Then we have the maybe sales table. If we've made a sale, what exactly we are doing. Then we have someone also saying the category table to be able to know, okay, we have a category, like you can see while we are here, we can see that we have maybe within the beauty is a category on its own. So we have fashion, we have gaming, we have baby products, sporting products, home and office, supermarket. So these are the different categories, or these are different, these ones. I'm sure if you go to their database, you will see that they have a database for supermarket, health and beauty. Like these are specific data stored in the category table. So we've said category, we've said the products. Can we have some people? Okay. Can we have someone raise their hand and just give us besides the product, besides the product and the category? Do you have something that you want to tell us? Yes, Lorna.
Oh, so when I think of the umbrella term, I'd say the database name would be something like Jumia. And then under Jumia, we'd have different tables like health and beauty, home and office, etc. But then the database would be something like Jumia, maybe online selling system or something like that.
Correct. So the Jumia is the bigger term, that's the database name or the schema name. Then under that we have different products or different tables under it. Okay, fine. I think we'll get into details about this, but now something else that I've seen on the chart that I need to address. Gideon, you're saying product ID, product price ID, product name, price discount. I wouldn't say these ones. These are not tables. These are now what we call attributes or fields within our table. So think about it as a basic SQL table, basic, even Excel. I know we don't like SQL, but just Excel and all that. But the most important thing is what you need to understand is every time you create a table, we are saying that the table stores related data, right? So right now we have a table called products, and we are storing all the products we have on our site, right? We need to be able to know for every product, what kind of information are we collecting based off of our product? Let's say now we have this TV. We have this TCL TV here. You can see what is maybe based on how this information is stored or is displayed, this TV is displayed, what are some of the things, or what is kind of what are some of the attributes that you can maybe get from it? Like, what kind of information do we have stored in our database for us to be able to display a TV like this with this page? Anyone wants to help us? Anyone wants to help us? Yes, Sharon.
So we'll have the image,
Mm-hmm.
the description.
Mhm.
We also have the price, and
Mhm.
maybe the one for the official store, because it will be a specific location or a certain store is selling. So maybe store.
Okay, so the store that is storing. Okay, nice. I think you've covered almost everything that we need to store about a product, because we have the name that you said, which is TCL. Then what? Then the brand. Brand is also some information we are storing in our products table to be able to capture the brands of different products. Then we have the price of the item. So every product has different products have different prices, so you have to capture that within your database. Then there's also something called there's the stock. You can see that they had a couple of items, they've sold a couple, now they have 55 left. So you need to keep track of how many products are you storing. If someone buys, can you also now maybe subtract and all that? So you can see there's also now the product details, the images, and the different parts of that. So you can see that just just by thinking about it now from front end to back end, we've been able to know, okay, if we wanted to build something like this, we need to be able to think about, okay, we have what's the collection of information that we need to store separately, and how can we store it? What fields can we take note of, and how can we design that? So you've been able to engineer this from ground up, really. So very, very important. We'll get into the details of that. Yes, and thank you guys for, yes, there's also someone saying that there is a review, because can you see this? There's a part for the ratings. This one has 17 ratings, and we have the star ratings to see how many people have reviewed it. You can see it at the very bottom here. You see maybe people have reviewed the product, the ones that are verified, what they say, and all that, the star ratings and the description of that. So you can see that you need this information related to a product. But now I want to now introduce another concept that we have in databases that is called database relationships. We said that SQL is about database or data and how data relates to each other, how different tables are related to each other. So based on this page, which I've shared on the chat, is there something that you say, is there any information just from this page? If we said that we have a products table, which other table can we create that is related to the products table, and why? So based on what we have here, do you think all this information should be within the product table? And if not, which other table can we create to link this data? Okay. Dan Mutua, you say brands. Mm-hmm. Okay. So think about it this way, right? We think about it this way. Right now, we have a product. We have TCL as a brand, but we are just looking for a TV. And now, when we search, when we say maybe we are searching for smart TVs for Jumia, you see different brands. You have Vitron, we have Vision, we have TCL, Hisense, Skyworth, Weon. All these other brands we have different products that they are selling on our platform. So for this data to be structured well, you need to be able to say, okay, I need to make sure that we don't have redundancy. For example, under TCL, right now, we have a lot of TVs here. Now imagine having to do that over and over and over and over and over again for all these ones. How about we create a separate table, call it brands, such that within now the after we within our database, then we can be able to store all this data and make sure that the data about brands, the official brands that we have on our site, then tie every brand to the products that it is selling. So, and how does this work? You need to make sure that you know which data is related to which data and how you can merge the two. So maybe someone is also saying something else. Someone else is also adding a reviews table. Okay, reviews table, like what we said. If we look at this TV, someone has bought it and they liked it or they didn't like it. So we have review. We have this person saying it's a perfect picture clarity, value for money, remote is dead, is not funny. Okay, I'm sorry to this person, but yeah, you can see the different reviews. You can see the different reviews just under this product. Now imagine we have Jumia is working maybe in several countries right now, but in just Kenya, we have so many people that are on the Jumia site every day buying things. If we had to make sure that within our product table, this review is also going there, all these reviews are going there, we will have so much, our data will not be structured first, our data will also be lost, and also now it will become so hard for our users to be able to work with our site. Because if I come here and I search for something, it means that it has to go through multiples and multiples of queries for me to get what I'm looking for. But if we structure this data into the different products, relate them well, then we need to make sure that can work perfectly, right? Then, so that is the concept of relationship, being able to store data in different tables, then use the relationship between one table to another to make that connection, to make sure that by the time you make queries to your database, then everything should be up and running, or it should be optimized enough to make sure that your site does not lag, for sure. Then it also makes sure that your data is easy to use, and also your queries are optimized enough to make sure that your site, the backend of the database of your site is well engineered, for sure. So database relationships are very, very, very important. So and that is one of the key principles of database engineering. That is under data modeling and design. Then other principles are on data integrity and constraints. So data integrity is like this, right? You have a list of products that you're storing you have data about products that you're storing on your site, right? Right now, you need to make sure that maybe you don't have the same product appearing twice, or you need to make sure that you don't have the same data about a particular product repeating multiple times. How can you do that? You make use of things called database IDs and primary keys. So that means that every product is tied to a particular ID to make sure that the data is not redundant. Again, it goes back to something called performance. You need to make sure that by the time you're storing your data in your site, you need to make sure that you have it's well structured enough to make sure that it's not redundant. Then now imagine if we went to Google and searched for something and it didn't give us what we were looking for, or it was trying to figure out, are you looking for Vitron smart TV or are you looking for something related to that? Or it will give you so many redundant stuff that you're not really looking for. So you need to make sure that your data is well structured and has enough constraints to make sure that. Another example would be if users sign up to Jumia, you don't want this one person using the same email twice, signing up twice, or you don't want, if you are giving a report about how many people are using your site, are you giving that information based on repeated users, or is it concrete data that you're reporting on? All these are very, very important. Another principle that you need to think about is query optimization. Query optimization is like this. You have millions of data or information that you have. Now, if someone is looking for a particular thing on your site, how do you make sure that the search is fast and also it's accurate? So you need to think about, if someone is searching for a particular product, you need to make sure that by the time they are searching, you need to engineer your database in such a way that there's a way you can optimize the queries, or to make sure that in as much as you're looping through thousands and thousands of data, you need to make sure that it's faster and can give the correct results. Other things, so we'll get into the query optimization in a bit, but the most important thing that other engineering principles that you need to think about are security and control and access control. You don't want everyone to be able to access your database. Is this data encrypted? Is it do you have authentication authorization on your site? Now that you can take care of this at the back end, and it also needs to work together with the front end to make sure that maybe you can't check out before you sign up. Those kind of controls to just make sure that you take note of your unique users, your unique purchases, you can track your orders and all that. The other thing, as a database engineer, you need to think about, how do you back up your database and how do you recover in case of an issue. We get into that, hopefully. Then another thing is, as your site continues to grow, you started with 200 users, now you have 3,000 users. How is your database? How scalable is it to maybe accommodate new users, new data, and how much? And also something else is on availability. How much? How is it in terms of now query and storage? Where are you hosting it? How much is that costing you? And also now, how is that adjusting to maybe its growth and all that? Then we have something else on documentation and maintenance. You're not, maybe right now you're thinking from a place of a developer. We are developers here, hopefully. So the most important thing that you can do is maybe think about, okay, hey, I've created my database, I've hosted it, the site is up and running. What else do I need to do? Maybe let's say you are working for company X. You're not going to be in the company X for long, or maybe you're not going to be there forever. There might be someone else who needs to come back. And also maybe based on all the projects that you're building at the same time, you need to be able to know where is what. That's where documentation comes in, because there's a point where maybe something has changed and you need to modify your data. You need to maybe expand, add a field, add an attribute, all these things, add up a table, all these things, you need to be able to keep track of that. And that's why documentation in software development, whether backend, front-end, or full stack or mobile, it's non-negotiable. So you need to think about how to keep track of all these things. So those are like the basics of the principles of database engineering. So I don't want to, because time is running out and we only have like 30 or 40 minutes left, let's get hands-on, right? Give me a minute. Let me open my VS Code. Okay. Vincent, you're asking a question. Okay, Vincent, you're asking where does normalization come in and when dealing with SQL, and is it essential? Good question. So when we talk about normalization, it's usually being able to structure your data in such a way that you eliminate redundancy and integrity of your data. So there are different ways that you can do normalization, right? So think about it this way. Let's say you are just storing users, a portion of data about your users, right? So the users, you need maybe the first name, the last name, the email address, the data related to the users of your site, right? Now you've gotten to a point where you need to think about, okay, if I just joined first name and last name under one name, under one column, how is that going to affect maybe my search? Or how do I make sure that people don't have similar names, or to make sure that by the time someone queries a particular record, that it gives them as accurate results as possible? Then you come to say, maybe I need to normalize this data, this table, to make sure that maybe I separate full name from, I separate the names from from our complete name or our full name to maybe first name and last name. Another example would be, right now we are working with products and e-commerce site, right? Some of the things that you need to think about is this. Are you able to, can you separate maybe the description from, can we separate the description maybe from the name? And how do we store this data in such a way that if I'm looking for something, right, or if a user searches for a product, a certain product, can we check base both on the maybe the description and also on the name category, just to make sure that your site is well optimized? Very, very essential. Very good question. The other person is asking, so the data engineering portion is the organization of data in an DBMS, correct? Correct. Okay, yes, this is also one of the things that we'll look at. It's on caching. So right now, within our Jumia, even if we close this tab, we should be able to come back and see maybe some of the recently viewed products or something like that. Or if you have something that keeps on being searched on, then you should be able to cache it in such a way that some of the queries, they don't need to go directly to the database. So that is very, very, or doesn't necessarily have to go back and query all the way through. If you implemented caching, you should be able to just quickly look up and give you the results that you're looking for. What I want is, I'll be using VS Code. So at the very basic level, if you want to use VS Code for your databases, you need to have something called, you have to install this extension called SQL tools. So when you have that and you install it, then you should be able, this is what I have installed. So it helps me to basically create my databases from here, view it, access it from here directly. So but then once you have SQL tools installed, then it will bring you this icon here. Can people please at least tell me you can see my screen? I need to make sure that at least we are together in this one. Can you see my screen? Okay, good. Yeah, so I'm on VS Code. So when you have the SQL tools installed, you can go directly there and create a database connection. Right now, I had created a database connection here called my database connection, but just for demo purposes, let me create another one. So I'll click on that connection link. Then it will give me, so SQL tools, you can either use it for MariaDB or MySQL. We're using MySQL for this one. So, but the most important thing now, it will bring you this to this particular point, and you need to create a connection name. In this case, we'll say maybe we are saying, let's call it space here tech. Then we can call it space shop. Then my database name, my username is called SQL user, and I have a database password that is here. I'll change it. I know. Can you guys hack into my machine? I'll change it, but you've already seen it. Okay, then so I put a password there, then you are good to go, so you can save it. Then I can say connect now. And you can see that it's saying that there's an error, connection bad DB error name, because they can't find a database called space shop. So that is an error that we need to figure out. So before we can get there, let me get to my terminal and open my SQL. So you go to your terminal, type MySQL -root user -root, then in this case -p, then I enter my password. Then you can see I'm on there right now. So if I find which databases I have, you see that I have some of these databases. So I need to create a database called maybe wait, yeah, we said the space here text says that a non-database space shop. So what we need is we need to edit the connection. But before we can edit the connection, I need to take this database name and come back and create it. Create database, then space shop. You can see that when I find databases again, you can see that space shop has been created here. So let's try and come back here and see if we can test the connection again and see if it says that it has successfully connected. So what does that mean? It means that now we have our database. So the only thing I've done is this. I've installed an extension called SQL Tools, then clicked on it, created a new connection, called it Space Attack. Then within that, I created a connection details and say I give it database name and my authentication details there, and created the connection, which is we are good to go. So the most important thing right now is to create a database. Right now, we need to create a database here and say we've already created the database, so we need to create tables. As an SQL now or database administrator, you need to think about, we've already gotten into the details of what exactly we need to create, what exactly we need to have in our database, what tables we have. But just for reference purposes, at an high level, if we were building an e-commerce application database, we would need different components under it. But for right now, we need maybe user management. How many users would we need to keep a record of the users in our database and who they are, their details. We need to create but under user management, you still need to think about the users and their roles. Do you have the admin? Do you have a user who is a seller? Do you have a user who is a buyer? All these categories. So under user management, that's a whole component on its own. That's why when you think about when you're creating a product from scratch, or when you're creating an application from scratch, when you think about it back end to front end, it helps you kind of get a glimpse of what exactly you're building. Like it helps you visualize your site at a whole new level, because you know what exactly you need at what kind of modules or what kind of components you want to build. So and you can have the user management component, you have the product catalog. And the product catalog, you need to think about the products, their images, where they are going, and the categories, right? Then under shopping, cart, and orders, you need now to think about, okay, if someone adds to cart, where do I store that data? If someone now goes ahead and clicks on checkout, can they now, do we have maybe a table storing some of their orders, and how can I track them? Is this order processed or not processed? Is it refunded? Has it been paid for? Those kind of things. And we have the reviews and ratings. Like we said, like we saw in the Jumia, we have to keep track of who reviewed what, how much was the rating, and what did they say exactly, like what's the description of the review. Then we have something else for payment, we have to think about payment and transactions. Every time maybe someone makes an order, is it pay on delivery? If it's pay on delivery, or is it maybe prepaid or something of that sort? How can we keep track of the transactions that we are making on our database? Then there's a whole component on seller management. Maybe this is an open source quote unquote application. We have different sellers or different people who are selling or offering different items. How can we make sure that we keep track of that? Then search and recommendations. If someone searches for something and you want to cache it to make sure that by the time someone else comes back, you can see maybe what you previously searched. I'm sure that you've seen that in most e-commerce sites. Or that there's also another aspect of security and logging. So logging specifically is very important when it comes to database engineering. The most important thing is for you to be able to keep track of the most important events, or if someone made a transaction, are we able to log this information to make sure that by the time we come back, we can see maybe we can look back and say maybe at this particular point within our application, this person made a payment, and to keep track, just to make sure that when we are debugging or when we are being audited as a company, can we come back and realize that, yeah, every specific activity or event within this application has been tracked. So that's mostly just on a high level, some of the components that you need to have within your e-commerce site, right? So when we talked about data modeling, we talked about different tables. This is just like an high level example of what we will be building with SQL, but we said we'll have a users table, and a user we need to keep track of their username, their email, their password. But we said that our site has multiple users or different categories of users. Someone can log in as an admin. Let's say you work at Jumia, you need to have a different level of access, like your permissions are different as compared to maybe a user who just wants to buy. So we need to be able to differentiate that in a table called roles. So the roles, basically, it's about being able to know, is this person logged in as an admin, or are they a seller, or are they a buyer? If you are, even think about it from this point, in an interface, at an interface level, you can say that if you log in as a buyer, you should be able to just see a list of products and check out, right? But now, if you log in as a seller, you should be able to manage your own catalog of products that you're selling and offering, and see maybe if the quantity has changed, if you've made a sale, and generate reports related to that. So that's why we have to relate these two tables. So then we are using something called, for us, we said that when you talk about SQL, we talk about relational databases, and we are also talking about how they relate with each other, or data relates to each other. In this case, we need to relate the users and roles together to make sure that we know our user is within the user. When we store the data of a user, we say maybe the user is, maybe let's say Brian, their email is brian@gmail, their password is 123, but their role, instead of redundantly storing that role, admin or user or seller or something, we can have a separate table for just our main categories of roles. Then you can use that as a foreign ID, foreign key. So what that means is Brian, if an admin is on ID 1, then we have that within the users table when we are adding a record. The same case applies to products. Products has to be related to categories. In this case, a category will be a foreign key within the products table, because the different products have different categories, or a product belongs to a category. That's why we have a foreign key within the products table. The same thing then, imagine now we are building a site and we have multiple images for every product. You don't want this to be redundantly stored here. You can structure your data in such a way that you have a separate table for just storing product images. Then for every product, you can just link it to the product, the image IDs, or a collection of its IDs stored somewhere. I wanted you to see this so that if we start building it on the SQL, you should be able to understand what we are doing now. Okay, so right now, When you go back to VS Code, so right now, since I'm operating from a different, if we are trying to, if you're asking a question, just raise your hand so that Lawrence, Jimmy, you can help me get a hold of those questions from this other side. So right now, just by clicking on that and clicking on the SQL to see. Yes, someone has a question?
Yeah, I wanted to ask about the surrogate keys. You talked about foreign keys.
Uh-huh.
You've talked about foreign keys and primary keys. What about the surrogate keys?
Okay, so surrogate kids are mostly related to how data is related. Like, for example, if you have maybe like a many-to-many relationship and you want to create an intermediate table, then you have to think about it. But the very basic level, for our use case, we don't necessarily need a surrogate key, since the primary and the foreign key work just fine.
Okay, thank you.
All right. So so once you create the connection for your database, you need to come back and see if it's working. I just ran this query and said that if you run, then I can see a list of databases I have on my machine on this under this connection. So you can see I have it here. So and since we are using a table called space shop, so we need to say use space shop to be able to link every other query that we are making within our application. At the very basic level, we need to create maybe a table called rows. So what this means is we are just creating a table to hold the different rows that we have in our database. So in this case, we call that table, like we saw, I'm just using the same copy we have on here to be able to just demo a few concepts here, then we'll call it a day. So we'll create a table called rows. Then within the row, then we have the different columns, stroke attributes, stroke fields, right? The different attributes of the table now get in here. So we need something called a role ID, which we said that is very important for every database table to have a primary key. And in our case, we say it's auto increments. When you talk, these are called constraints. We could easily just say it's a role ID, but we need to specify the type. It means that this data can only take an integer. It can't take a string, it can't take any other data type aside from an integer. Then it shouldn't be null. That means that it can never be empty. But the good thing is it's auto increments. So what that means is every time you insert a new value within your database, you don't necessarily need to specify the role ID because it's already created, right? It's already auto incremented. So that means that if you're at number 2, the next record will be at number 3. So that's what really it means to create a database table, its attribute, and specify the different constraints and data types to it, right? Then the other thing that we need is the role name. So a role name, and this role name is varchar. So what does it mean to say it's a varchar? It means that within this varchar, we need that the names needs to be a string. The name needs to be a string to make sure that you're storing maybe a collection of text, really. Then the other thing is we can also have something called permissions. Permissions is just being able to say, for this user, what can they do? Please ask your question. I'm here. Ask your question. Okay, so we said that.
Yes.
Uh-huh.
David, your hand is raised. Yeah, we can continue.
Okay. All right. So what we just did here, what we've just done here is we've created a table called rows. We've defined what kind of data we want to store in this table. We want to capture the name, the permissions. So the permissions is basically let me call it raw permissions just for consistency purposes. Then all that. Then I think you can see something here like quote parentheses, then some number there. That's what means. That means that reserve this amount of memory for this particular category or for this particular attribute to make sure that maybe we can only have like 50 characters under this. Maybe a role name cannot exceed 50 characters, so reserve that memory space in my database to just store that. Then also for role permissions, it means that if someone is an admin, what can they do? Like what are some of the, in terms of authorization, what can they be authorized to do within this? Or if someone is a seller, what can they do? What can they not do? Those kind of things. So then there's something else for primary key. We said that a primary key uniquely identifies different values or different specific columns or the specific data within a particular database table. So you can see that. Yes.
Sorry, I had internet issues. I wanted to ask, what's the difference between varchar and string? Why don't you just use a string?
Okay, so within SQL, varchar is like the reserved word to mean string. But if you were creating maybe description, then we would use maybe text or long text to mean. So it's just a matter of what is reserved within SQL and which one is not. So we use varchar instead of string.
Thank you.
All right. So I want us to create a product, a users table, just to link the two. So I've just copied and pasted, guys. It's the same thing. So I've created within the users table, I need to capture a couple of things. The user ID. So I just change this to user ID. I need to capture the username. Then the other thing I need to capture is their email address. But the email should not be null, for example. So I'll just add that constraint there. The primary key in our case is user ID. Then the other thing that we need to capture is maybe their password, because they may need to log into our site. So we need to capture a password, say it's a varchar, and say maybe it's supposed to be 200 because we might need to encrypt it and it might get longer. Then it means that the password cannot be null. Then the other thing that we need to do is relate these two tables. We said that a user belongs to a role. And that's why I created roles first before I can get to the user. Because by the time you create a user and you tell it that there is a column here called role ID, it will start wondering where this role ID is coming from. So it's role ID int, it's not null. Then you now relate them. This is where the relationship comes in. You specify that role ID is not a custom attribute here, it's coming from the roles table. So what that means is after we create the primary key, we need to create a foreign key. So foreign key, we specify this is the role ID and the role ID references. So references is a keyword that shows that role ID is coming from the roles table. So it means that it's coming from roles into user into role ID. All right. So also something else I need to take note of, every time you create a new part, you need to put a comma at the end, but at the very last one, you don't create a comma. So what have we done? We've created a users table. We've specified what the user, what kind of attributes you're collecting, and we've specified a role ID, which is directly coming from the roles table, and it's coming from there. So before we go any further, let's run this and see if it creates the table. All right, so it says that I have a syntax error. So it says I have a syntax error. It's coming from my SQL. So let's see. Let's run it one by one to see if that, okay, it still says that I have a syntax error. So let me try and do this. Let me specify the database like that. Then just run the selected query. Then I can say, okay, let me use that for the both of them just to be able to specify that I have different databases, just to make sure that whatever I am running makes sense. Okay. So it still says that I should check my syntax. This is why you guys come in to help me debug. All right, so create table looks just fine. Looks just fine. Looks just fine.
Hello,
Anyone?
hello, Faith.
Yes.
I currently have not checked to see where the problem is, but what could be the problem? What do you think SQL brings issue is with? Like if you can check the closings, like the commas, rather.
We are making a good progress.
Like for the benefit of the audience, like if they, because these issues are there, so like where do they, what kind of brings, what is common, like what could be the issue with the SQL, like if they get a syntax error like that,
So
like where do they start checking?
Where do they start checking? Yes. All right. So when you have an error like this one, can we solve it first before I get ahead of myself? Then we can't solve it. Then we call it the night. So let's check first and see where the issue is coming from. Then we can try and.
So if you can comment out the other bits, the second table.
Okay.
Then you try to run it.
All right. So it says that we have an error.
So in the first table, it should be the first table. So the primary key, do you need the last closing comma in the last field? Can you? Try at the very last one.
No, you do not need it. Okay, let's try and run a query here. Just say maybe let's say show tables. Let's see if this one, okay, let's show databases just so that we see if this one works. Okay, so something is wrong here. So it says that I still have
does it show the line?
It doesn't.
Or the description, is it pointing to a line?
Everything looks okay. I think it's more to do with the connection, maybe.
Yeah, it looks like. Oh. Okay, so it says that no database has been selected. So nice. So it says that.
Now, can you try like okay, the second table is having a lot of foreign keys. Could have tried with the second table.
It
Or can you
already
just try
says no connection, so let's sort the connection first.
It's a connection issue. Okay, let's basic IT debugging issue. Disconnect, then connect again, and let's see if it works. Let me just run this one just to make sure that. So it says that no database is selected. So let me copy this and put it somewhere. Just put it somewhere as a draft. Then I can make sure that I can query again. So say maybe show databases. Then I can run that. Says that shows the databases. Then let me comment out this one. Sorry. Then you can see if it works. So it says that I still have an error in my wait, it still says that I have an error here, which I do not understand. Okay, it says that cannot read properties of undefined. Okay. So it says that there is no table called space.shop.space.shop. So we don't have that. Then we go back here. This should be fine, or okay. Whew. This was a problem. It's supposed to be auto increment, auto underscore increment, not auto increment. Oh, okay. Okay. So it's supposed to be, let me just check if we have any other error, because this was definitely the error. This is how you spell auto increment. Then worker, then not now, then all that. So let's try again. So it says that table roles already exists. Whew. Okay, finally. So it shows that it was created. So when you go to Space Shop under tables, sorry, let me expand on this one. When you go to Space Shop under tables, then you should be able to see the roles table has been created. So that has been created, thankfully. So since we don't need that, then you can delete it. Then we can create the second one. I hope people have been able to understand where the issue was coming from. The issue was coming from auto increment. The auto increment is supposed to be, let me close these tabs so that you guys can see. So auto increment is supposed to be auto underscore increment, not just auto increment like that. So if we run this, it says that we have an error again. It says that we still have another error. So where is the error coming from? So the user ID, username, email, password, role ID, It looks just fine. Or is it me? It looks just fine. Auto increment like that. What? Okay, so we are still back to the same errors, and this looks just fine. Anyone with a solution that I think it's just something like what you are just having, but auto increment works. Then username, worker, not now. This. Okay. Ooh, this is not looking good on us because we need to move faster and time is running out. Right. Okay. It has been created. So the table has been created. Okay, sometimes you wonder why these issues are coming from, right? Okay, so for now, since we don't have as much time left, let's try and insert some sort of data and just see how that works. So after you've created the two tables, you can see that within the roles ID, we can have the columns that we have installed there. We have the same thing. You can also see that it's also showing that the role ID is a foreign key to the roles table. So we just work with these two so that we save on time. And so that I can also show a bit of what I was talking about when it comes to if you are inserting data. Now, if you are working with data now, if you're working with both the roles and the user, the role comes before the user. So it means that you can't reference what does not exist. So it means that if you are inserting data, it means we need to start with roles, and the insert query is the same. So you insert into roles, then within the roles, you specify what kind of data you're working with. So, but you have to specify the columns first. So the role ID, these attributes that we had there. But in this case, we are not really inserting the role ID because it's auto increment. So we have the role name, then the permissions. So then after we specify that, now we need to specify the values that we are inserting. So in our case, we need to insert values like maybe we can have a role called a customer. So we have a customer, then we have a customer and their permissions. So it needs to follow the same order. This is role permissions, just the same thing we had here. Then you can say maybe a customer can add to cart. So what that means is we have a list of customers that if you're a customer in our application, you should be able to add to cart, and these are your permission. The permissions maybe you have. We can have just that one permission. Then you can have a seller, and we can say a seller can create products. That's their permissions. Then you can have another person, another role. So these are different data there are different types of data that are being added. You can say an admin, and an admin is manages everything. Let's say that's a permission that we specify in our application. So this is how you insert data into your SQL database. And once you've created that, you need to be able to create the linkage, right? So as per the usual, since this data is being added one by one, like row by row, everything that is related to each other needs to be in parentheses. And that's basically how it's supposed to be working. Yeah. Then the other thing, that should be fine with regards to how to insert data. I am not sure if we need this, then we can see how that works. So we insert into space shop.roles, role ID, and what that means. If we run this, it says that cannot read products of undefined again. Okay, so let's see first to see if we can select everything from the roles. So we need to specify the database. So we say space shop.roles. If we do that, and we comment out this one, we should be able to see, it says that it's undefined again. This is, if we look at, oh God, there's a problem with my VS Code for sure, because I ran that and it gave me an error, but it worked. So you can see that everything that we've added to our table works. Like we have the customer, we have the seller, we have the admin, and we also have their role permissions and what that means. So you can be able to add data. So if you wanted to add another data for users, or the users, it will be the same, but you still need to specify the username, the user email, the password, the same thing over and over again. Username, email, then password. So let's say our first user is Joshua. Let's say this is John, this is Mary. Their email is joshua@gmail.com, and the other one is john@gmail. Then the other one is Mary at Gmail. Then the password, you still have to include data about password. Let's say that is like that. Then the same thing here. Then the same thing here. You have that, should be able to insert into users. So username. So but then we have the role ID. The role ID is the role based on the different roles that we have. We need to be able to specify, is Joshua an admin? So we say Joshua is, so this ID is the foreign ID that is related to the ID of the data that we have within our rows table. So we say maybe this one is number 2, this one is number 3, depending on their different categories. If we run this, of course it says that, let's see if it shows the records. You can see it has added our different users on our site, right? So what have we been done? We've been able to create a database, create tables, then insert data into it. The other basics are just being able to manipulate this data to be able to update, be able to delete, be able to drop, and all that, which is far much that will depend on what exactly we want to create in our database. The most important thing is being able to understand which tables do we need, what kind of data do we want to store based on the attributes, then how is this data related from one database to another, and how can they work together. The other thing that I think everyone should be able to understand is within the relationships, do you know how the data relates with each other? Like if how the data relates is like this. A user can only, maybe you can't have a user who is both a seller and also an admin, right? So you need to be able to differentiate and say, maybe this user, this relationship is one-to-one because a user can only belong to one role, right? Then you can have another one, like a product can belong maybe to one category, or can belong to several categories or something of that sort. Then we have many to many. A user can shop several products and all that kind of thing, and then products can be shopped by many users. So that is something that's a concept that you can read further on. Then at the very basic level, you should be able to understand, how do you create, how do you insert, how do you delete, how do you drop, how do you update. So these are like the basics of what a database what a database administrator should be able to understand when it comes to designing their own database. Then I wish we had covered this one, but time is not on our side. So hopefully in the future I'll come back, because I had some things prepared to show you. How do you create a cache? How do you optimize? How do you query a database? But now in that case, it means that I'll have to come back with a database that is already populated. Then you can get into the details of if we query this one, it takes maybe this number of time. But when you cache it, it takes this number of time. I wish we can be able to simulate that, but we should be able to do that in the future. So this is something that you can see much on or read more about on. If you have data stored somewhere, how do you make sure that you can cache it? How can you index it to make sure that your queries are faster? How do you partition your data? How do you cache it? This is something that in the interest of time, we will not be able to do it today, but I'm hoping that you can read more on it. Then maybe in the future we can have a discussion around it. Then we talked about security. Now you have to think about, if you look at what we just did with our database, if we look at our database, everything here is just, the password is like, it's just as we inserted it. That means that it's not secure enough. We need to figure out in SQL, how do you encrypt to make sure that someone else, if they do something called SQL injection, they should not be able to find data that they can hack into your site? Or is your database secure enough that someone else cannot read it? So how do you ensure security of your database? How do you encrypt? Very, very important. You need to think about that. Then when it comes to logging, it has a lot to do with how now the events within the database, within the application, are tied to the database and kept track of. Yeah, but that would be it. But I'm ready to take any questions that you guys might be having. So ask any questions you might have.
Yeah, Faith, thank you. Yes, Shadrach, you can unmute and
My question is, can a database harm? For example, how we see sometimes when an app is hanging, for example, YouTube is like loading there, loading. Does a database perform like that at sometimes?
Can you repeat? Sorry, can you repeat the question?
For my question is, the database that we are creating, can it come to a point whereby there are so many users at a time, whereby it's like hanging? Or like, for example, YouTube, when there's some time when you're trying to connect to a YouTube to watch a video, you see it's like buffering there for like 10 minutes. There's nothing that is coming on the screen. The database, like, can it on the back end experience such a situation, and how can you mitigate that situation?
Okay, that is under query optimization, and has a lot to do with, right now, if you are building a video-based application right now, you might have to think about, how do I store this data in such a way that, like, for data that is related, I mean, everything is stored in the internet, right? But within that, on the internet, there are now a lot of factors. When you search, is it loading? Is the loading time now dependent on the internet, or is it dependent on how you've stored your data? I said that there's something called indexing, where you make sure that if someone has searched for something specifically, let's say they've searched for a video on how to create a database in SQL, there's a video related to that. You need to make sure that your queries, there's a way that your database is optimized enough to make sure that whatever search term that someone has entered is specific enough or can be indexed to be able to specifically retrieve that information. But there are a lot of factors also now dependent to that on your internet bandwidth and how you've structured that. Is it a link or is it a video that you've already stored in the server directly? So that kind of thing. Any other question? Any other question?
Yeah, maybe from the chat.
Mm-hmm.
From Kinoti. Under what scenario do you use non-relationship relational database, and how do they store their data?
Okay, so we said that non-relational database is about if the data is unstructured. And I gave an example of if we are collecting information from different parts of Kenya on maybe different projects that the government is doing, we realize that maybe the structure of data that is coming from county 041 is different from county 015 so you have a lot of data that is unrelated but important. So in that case, you'd rather just collect the information and store it than try and create tables and relate them for something that is unrelated. So another scenario would be this. For this particular example, like if the data coming from Nairobi is different from the data coming from Machakos, then you'd need to make sure that the two are equally important. So the data is not necessarily related, but it's equally important. So you just store it as it is without necessarily trying to remove redundancy or trying to relate it to anything else. So it's non-relational. You'd use it for maybe project-based data collection kind of scenarios as compared to user-intensive ones where the data is related. Grace?
Okay, thank you, Faith, for your presentation. Please share your slides before you leave.
All right. I've shared it on the chat. I've shared them.
Hello.
Yes, Kevin.
Hello, I have a question.
Mm-hmm.
I have a question on, okay, after creating your database, and then you said you are also a software engineer, right?
Mm-hmm.
Hello?
Yes.
Okay, on licensing, how how will you know that a person is using your software?
How will you know?
I just wanted to know, how will you know
How will you know
that
someone is?
maybe a user is using your software basing on licensing?
It's like I don't understand. Are you talking about it from, okay, you have a site somewhere and you want to keep track of who is using it, or is it, or who has stolen your work, or please, kuna venye I do not understand that one. I don't know if I get it. Or Lawrence, do you understand what he's asking?
I also don't get the question exactly. So maybe if you can elaborate it more, like in terms of data theft, or what exactly do you need to know? Like who used your website,
Like
or
you've created a software, then it's requesting for license and stuff. So how will you know that a person is using your software, so that maybe you can block all? You don't want to maybe use a license, something of the sort. So how will you know that a person is using your software, so that it doesn't require a license?
like in terms of how we model our data, or is it related more of the data that we've been handling, the databases, or you
Yeah.
mean?
No. I think on my understanding is that not on the data end, but he's talking about licensing and maybe patching. You've got your software that you've licensed it, but
Yeah.
maybe someone is using your software, has patched it.
Yeah.
On the other end.
Yeah, I think
How
you
do you
got it.
monitor your licensed software.
Yeah.
Okay. I think when it comes to tech and legal policies, and it's a whole ball game altogether. But I mean, everything that you create, unless you IP it, how would they know it's yours? So it has a lot to do with your being able to get an IP of maybe the product you're creating. And now it also has a lot to do with what are some of the security measures that you're implementing to make sure that you can keep track of that. I am not well conversant with legal and policy matters in terms of when it comes to tech. So I wouldn't be very, I don't know if I'll be able to answer that question, but it's something that I might look at. Samuel.
So my question was, what's your reason for choosing to write SQL commands over using the SQL GUI interface?
The SQL commands give you it's about flexibility, really. It's about flexibility, and yeah, it's about the flexibility of that, and gives you highly customizable features as compared to the GUI. But it also depends on what kind of site you're building.
A site in terms of
In terms of if you are building maybe a small application, and your database has maybe like less than 10 tables, and your data is maybe in the hundreds, not necessarily in the thousands, you don't necessarily you can easily just model that easily with a GUI. But now imagine if you're building a complex system with complex queries that you need to customize, and a lot of stored procedures, a lot of views that you need to create to make sure that interrelated data is efficiently optimized. You need to create custom queries that a GUI might not give you. Does it make sense?
yes, of course it does. Thank you.
All right. Shadrach, you have a question. I think you'd be the last person.
My question,
Mm-hmm.
I've seen that you are pursuing a master's in big data analytics.
Mm-hmm.
I had a question concerning artificial intelligence. Let's
Mm-hmm.
say I have a project, I want to make a chatbot.
Mm-hmm.
How will my design for the database be? Will it be like I will fill it with content, or how will that database for a chatbot? Can you just like give a brief description of the database relationship to my chatbot? Thank you.
Before you can get into the database of that, uh, anything that has to do with chatbot, you need to think about the machine learning behind it, the engine which processes that data. For example, you need to train data to be able to know if you tell this chatbot, how do you explain this? Or if you ask it a question, it needs to know what exactly you're referring to. So you need to design a database more a machine learning model to be able to train that data. Then after you train the data, then you can now create a database of maybe if you are using in machine learning, we have two different types. There is supervised and unsupervised learning. In this case, I think you need more of a supervised learning, because it's like garbage in, garbage out, based on how you've trained that data. If I ask this site, maybe where can I get maybe the nearest liquor shops in my area, then it should know what exactly I'm referring to. So that with that kind of dialogue, you need to be able to have maybe data related to related items or related terms, and maybe sample of related responses that is attached to different keywords. So you need a bit of natural language processing to know, because it's the same thing like when you ask ChatGPT something and it has maybe an error, or your type, it has a typo. How does it understand that you are asking this and not necessarily this? So if you are designing something like that, first think about the machine learning model and how you can train that data. Then you can relate possible responses with possible questions. Then after that, now you need to start thinking about how you store that. Then it's another whole ball game together, where aside from if you ask something that is not there, how does it respond? And also if you ask something that is not necessarily related, how does it compose a response? So I think it's more on the data training and the machine learning than on the database engineering, because you need the machine learning to be able to design the database. Does it make sense?
Yes, very nice, very nice.
All right. Okay, so I think that will be it from me. Please don't forget to connect with me, and yeah, let's connect and have a bit more chat on LinkedIn. I'm also available on Twitter. Then you can also check out my podcast. Yeah, but that's basically that's it. Lawrence, please.
And I'll also share your writings too.
Sure, please. Yes. Okay.
Just a request. Hello.
Uh-huh.
Just a request. If Lawrence and the other organizers, because that little bit of the optimization, the caching and indexing, I think it's more of important in handling this stuff.
Yeah.
So I'm just requesting if you can schedule a midweek session to complete that, if at all there's no continuation of this.
Yeah, I think we shall talk with I'll talk with Faith and try to organize on that.
All right. So I do tech writing. So I'll try and as much I'll create also maybe a more detailed site, a more detailed blog, especially, and cover more on the what is it called? I'll cover more on some of the topics that I mentioned but didn't really do much on. So I'll make sure I'll work on something like that. Then I'll share it with either Lawrence, but you can also find it in my social media platforms, especially LinkedIn and Twitter sometimes. Lawrence, back to you.
Yeah, Faith, I want to say thank you. The session was very informative and very interesting. So yeah, naona maoni ya watu wanasema tuongeze, we shall do another session. We shall talk about that with you, Faith. And to the audience, I want to thank you for being there for this session, taking your time for attending the session like this. To the speaker, Faith, this is more than appreciation for coming onto this session and to us. So for the recording, I think by the end of tomorrow midday, I'll share the recording onto our channel, that our YouTube channel. So, and also you'll get some articles, link to the articles to Faith writings and more of what she does onto the end. So my end is just to tell you good night and thank you all for being part of this session. Blessed night.
Okay, bye-bye, guys, and thank you for being here. I really appreciate it. Thank you for the opportunity, Lawrence, and goodbye, guys. Goodbye.
But thank you too.